Here we are, and welcome to lesson 22, talking about equations with variables on both sides, all in the name of I can solve equations. We're trying to get the variable by itself. The name of the game is isolate the variable or get the variable by itself. So what we're going to do is use everything we've learned up to this point to get that variable by itself. So now, the extension on this one is variables are going to be on both sides. And what you're going to find out is that we can do the same properties with numbers as we can with variable terms, as really they are just numbers. So those properties of equality work both ways here. So now, we want to solve the following equation. We need to get the variable by itself, but we've got variables on both sides. Oh no, what are we to do? Well, we can undo a positive 3a by simply subtracting 3a from both sides. Now, notice that the a term and the a term, this is your a over here. It's not going to affect the one that doesn't have an a because they're not like terms. So it's going to affect the ones that are like terms. So I've got 5 a's and I'm taking away 3 of them. So I've got 2 a's plus 9. Those 3 a's are going to cancel each other out. And I've got 59. Now, I've got 2a plus 9 equals 59. This looks similar to what we were just doing with two-step. We need to work in reverse order of the order of operations. So we're going to start by undoing the addition. Remember, addition and subtraction, we need to undo first. So I'm going to go ahead and subtract 9 from both sides, leaving me with a 2a equals 50. 59 minus 9 is 50. I need to undo a times 2. So I'm going to undo that times 2 by dividing by 2 and leaving me with an a equals 25. Now, I know that a equals 25. What I can do, and we'll do this one time and one time only, is go back and plug it into the equation. So it's a good idea for you to always do this. For the sake of time, I will not. So here what we're looking at is 5 times 25 plus 9. Well, 5 times 25 is going to be 125 plus 9 is going to be 134. And that is allegedly equal to 75. So 3 times 25 is going to be 75 plus 59, which is going to end up being 4, carry the 1. You've got 8, you've got 3, carry the 1, 4, 134. That's a goofy looking 3, 134. So we know that it checks out. Same story over here. Solve the following equation. One more. We want to get the variable by itself. So we need to get the variables. All the variable terms on one side, we'll get our constant terms on the other side. So what I'm going to do is I'm going to undo a positive 8. So I'm going to undo an 8x by subtracting 8x. And when you look at this, 8x minus 8x, these are going to wipe each other out from that side. So my 15x minus 8x is going to give me 7x minus 21. Notice how that's not affected by it. They're not like terms. Equals 14. Two-step equation. Reverse order of the order of operation. I need to undo addition, subtraction first. So I'm going to get rid of that minus 21. How do I undo a minus 21? Addition. So I got 7x equals 35, and I've got 7x equals 35. I'm going to undo that multiplication by division, and I'm going to say that my x equals 5. So then you go back to your original equation. Normally, this is where you'd go ahead and you'd plug it in, and you would get you would find out that they're going to end up working out pretty nicely. So that one's going to be 5. Solve the following equation. Ooh, we've got an extra step going on in between here. So now I've got 6 times the quantity, e plus 5, equals 9e minus 6. So with that, we want to get rid of these parentheses. This is going to make our life a lot easier. So we're going to distribute that number through, and that's going to give us, let me clear a little real estate here. That's going to give us 6e, 6 times e, and this is going to be plus 30, and that equals 9e minus 6. So now, a couple different ways you can go about doing this. I personally like keeping my e's positive. So what I'm going to do is I'm going to recognize that this is 6e's and this is 9e's. So what I'm going to do is I'm going to subtract the lower amount. So I'm going to subtract 6e's from both sides. Subtract 6e's, and what you're going to see is that you get 30 equals, I still have a positive 3e's. Preference, personal preference, you can do whatever you want. If you always like putting your variables on the left side, up to you. So I've got 30 equals 3e minus 6. So now, reverse order of the order of operations, I'm going to add 6 to both sides, and I've got 36 equals 3e. What I can do then is to undo the times 3 is divide by 3, and it's going to be 36 divided by 3 is 12, and that equals a single e. Now, this is technically right, but remember, we always want to have that variable first, so we know that it's going to be E12, because if you think about it like a definition, if you go into a definition book, what are those called? Dictionary, that's what I'm looking for. If you go into a dictionary, it usually says the word first, and then it says what the definition is, right? So this right here, it's kind of like the same thing. Your variable is your word that you're trying to define, and whatever it's equal to is the definition after. Imagine the mess a dictionary would be if it had the definitions first and then the words afterwards. Oh, it'd be horrible. Anyway. Which of the following are solutions to the equations below? So now this opens up the possibility that there is no solutions if you've got variables on both sides. So if I've got 8m plus 7 and 8m plus 5, take a look what happens here. I'm going to get my m's, I'm going to get all my m's on the left side. So I'm going to subtract off this 8m's. Well, when you look at this, 8m minus 8m is 0. So I'm left with a 7 equals 8m minus 8m is 0, and I've got 5, and 7 equals 5. What? That's not true. We know that's not true, right? 7 is not 5, so we know that this is going to be no solution, because 7 doesn't equal 5. There's no way that you can plug in a number here for m, the same number, mind you, for m, and make a true statement there, because in one you're adding 7, and the other you're adding 5. So in this situation, there's no number that you could possibly select. And that turns out because there's no variables left here, and it's just a 7 and a 5, and those two don't equal each other. False statement. So if you come up to something that's false, it's going to be no solution. Make sure you're doing your work right, though. Disregard this. I accidentally clicked on it, and it wouldn't let me unclick it, so disregard that. Right here, let's see if we get a solution. Well, let's go ahead and multiply. So I've got 5x plus 5, and that equals x minus 11. Once again, let's get our variables on one side, our constants on the other. So let's get our variables on the left side. So I'm going to subtract an x from both sides. 1x, I can say. So 5 minus 1 is going to be 4x plus 5 equals negative 11. I'm going to go ahead and undo the add 5, or the plus 5, or the minus 5. And this is going to land me at 4x equals 16, and that's a negative 16, right? You're at negative 11, and you're going down another 5. Let's get that x by itself one step further. By dividing by 4, we undo multiplication with division, and this is going to be x equals negative 4. And you can go ahead and you can plug that in, and you can find out that that is going to be true. So my solution is this, and it is not, in fact, this. So we can disregard that. And that right there is solving equations with variables on both sides. Get the variable by itself. My highlighter doesn't like to work, does it?